السلام عليكم أعزائي الطلبة. محاضرتنا لهذا اليوم هي طريقة الفيبونانسي Fibonacci Search Method. This search technique determines the smallest possible interval of uncertainty in which a minimum lies after completing an experiment. We have seen that the interval halving method reduces the interval size to 1/2 of its size in every iteration. Fibonacci search method, on the other hand, reduces the interval size by different factors at each iteration. The reduction follows a sequence number satisfying the following Fibonacci formula. Fn equal Fn minus 1 plus Fn minus 2, where n equal 2, 3, 4, etc. with F not equal F1 equal 1. Some numbers in the Fibonacci sequence are given in table 5.1. Note that the Fibonacci method can also be applied even if the function is not continuous. Even if the function is not continuous. Consider a unimodal function f of one variable and define the interval ab. We choose points a and b in such a way that the minimizer x star of f may be achieved in the following function. Evaluations. The table 5.1 Fibonacci numbers. This Fibonacci sequence F0 1, F1 1, F2 2, F3 3, and F4 5. Why? Because 3 plus 2 equal 5. And after that 8. We get 8 because 5 plus 3. And 8 plus 5 equal 13. And 13 plus 8 equal 21. And 21 plus 13 equal 34. And 34 plus 21 equal 55. And 55 plus 34 equal 89. And etc. This sequence equal a Fibonacci sequence. Let L0 be the initial interval of uncertainty defined by x greater than or equal a, less than or equal b, and n be the number of experiments to be performed. We present L2 star equal L2 star equal Fn minus 2 over Fn multiplied by L0. This the length of the interval A, B. This the length of the interval AB equal L naught, and this L2 star, L2 star, this or this L2 star equal Fn minus 2 over Fn multiplied by L naught. To determine x1 and x2 for the first two experiments, these 2 points are placed at a distance of L2 star from each end of L naught, which can be shown in figure 4.5. Which can be shown in figure 5.4 and expressed in the following form. This x1 equal A plus L2 star. x1 equal A plus L2 star. L2 star. A plus L2 star equal x1. And x2 equal B minus L2 star. And B, x2 equal B minus L2 star. And x2 equal B minus L2 star. And the length of the initial interval of uncertainty is L naught equal B minus A. Therefore, this L naught, this the length of the initial interval, L naught equal B minus A equal L naught. Therefore, x2 equal this term, and since Fn minus 1 equal Fn minus 2, therefore x2 equal Fn minus 1 over Fnb plus Fn minus 2 over Fna. Similarly, we can find the value of x1. We can find the value of x1 and the same method by this. This x2, we can find similarly x1. We find the value of f of x1 and f of x2 after the first iteration. Either a x1 or x2b will be eliminated by using the assumption of any model. In other case, new interval of uncertainty of length L2 is a similarly interval of uncertainty which is given as this. Hence, this we determine this interval AX1 or X2B. L2 equal L naught minus L2 star. L2 equal L naught minus L2 star. L2 equal L naught minus L2 star. And L naught minus L2 star equal f of n minus 2 over fn multiplied by L naught. And since fn minus 2 equal fn minus 1, then L2 equal f of n minus 1 over fn multiplied by L naught. And one experiment left this experiment will be at a distance of L2 star equal Fn minus 2 over Fn multiplied by L naught. And hence from one end and L2 minus L2 star equal this, and we get L3 star, and so on. L3 star equal Fn minus 3, and L2 star equal Fn minus 2 over Fn multiplied by L naught, and L3 star equal Fn minus 3 over Fn multiplied by L naught, and so on, and so on. And L2 equal f of n minus 1 over Fn multiplied by L naught, and F3 equal Fn minus 2 over Fn minus 1 multiplied by L2, and so on. This Lj star equal Fn minus j over Fn minus j minus 2 multiplied by L j minus 1, and Lj equal Fn minus j minus 1 over Fn multiplied by L naught, and Ln over L naught equal F1 over Fn equal 1 over Fn. And the ratio Ln over L naught is called the reduction ratio, which always asks to estimate the value of n, where n is the number of experiments needed to reach the optimum point with any desired level of accuracy. And this the algorithm of Fibonacci method. This the algorithm of Fibonacci search method. Choose A and B belong to R and N belong to Z plus. A and B lower and upper bound and N total and the number of this of experiment to conduct. Set F naught equal 1 and F1 equal 1. Let I equal 2 for I to N do. Fi equal Fi minus 1 plus Fi minus 2. Compute L naught equal B minus A, and compute L2 star equal Fn minus 2 over Fn multiplied by L naught, and J equal to, for J to N do, if Lj star greater than L naught over 2, then set x1 equal B minus Lj star and x2 equal A plus Lj star, else x1 equal A plus Lj star and x2 equal B minus Lj star. And if compute f1 equal f of x1 and f2 equal f of x2. If f1 less than f2, then set b equal x2. compute Lj star equal f of n minus j over f of n minus j minus 2 multiplied by L naught, else if f2 less than f1 then set A equal x1. Lj star equal f of n minus j over f of n minus j minus 2 multiplied by L naught, else set A equal x1 and B equal x2. Compute Lj star equal f of n minus j over f of n minus j minus 2 multiplied by B minus A. And if f of 1 less than or equal f2, then print x star equal f1 and f of x star equal f of x1, else print x star equal x2 and f of x star equal f of x2, and if.